Morning. So we're going to use vectors to solve geometric problems. So as usual, make some notes, get your learning objective down, date in Welsh. When you're ready, move on. So we're going to look at this example. So you can write the example down and sketch the diagram. So we have position vectors A and B in this diagram, and they have position vectors A and B. So we can write OA as A and OB as B. Then the point P divides the line AB in the ratio 1 to 2. So that's AB. It's divided into the ratio of 1 to 2. This is smaller, so this is 1, and this section is 2. Which means altogether AB is 3 sections. One section being here, so 1/3 of AB is here, and then 2/3 of AB is here. So we want to find the position vector of P. The position vector of P is given by OP, so we want to find OP. In order to find OP, we can travel from O to A, so travel along OA and then AP. So if I knew what AP was, then I could find the position vector. So let's write that down. So we can say OP, position vector we're looking for, is given by, let's make a better arrow there, is equal to OA plus AP. OA is fine, I know that's A. AP, however, is a different kettle of fish. I know AP is part of, it's a fraction of, a multiple of AB. So if I find AB, I know that 1/3 of it is going to be AP. So I need to find AB. So AB, now to get AB, I can travel back here, so negative OA plus OB, which is the same thing, so I'll write it here, as OB minus OA. OB is B and OA is A, so B minus A. Now, as we said earlier, AP is a fraction of that, so AP is given by 1/3 of B minus A. So that's our AP there. It's 1/3 of the whole length of the AB. Right. I can now work out OP. OP is given by, let's just write it again, OA plus AP. And writing it in full, OA is given by A and AP is given by 1/3 of B minus A, which is equal to A plus 1/3 B minus 1/3 A. So A minus 1/3 A gives me 2/3 of A plus 1/3 B. Good. So you can click pause, make some notes, and when you're ready, we'll look at another example. Okay, second example. We've got a triangle ABC. AB is given by, the vector AB is given by 3i minus 2j, and the vector AC is given by I minus 5j. Find the size of the angle BAC. So the angle A is what we're looking for. First things first, always draw it. So let's have a sketch of the diagram. AB is given like 3i, so 3 across and 2 down. And then AC is given by I minus 5j, so 1 across and then 5 down. So that's a quick sketch, and then we can join B to C, and they want us to find the angle A, BAC, so the angle here. That's what we're looking for. So I've got a triangle. I have no idea if it's a right angle triangle, which completely rules out then anything with right angles. Unless you know it's a right angle triangle, you can't use anything to do with right angles. So I can't use Pythagoras, I can't use SOHCAHTOA, they're all out. So the other formula that I have to do with triangles, to find angles in triangles, if you recall, are the sine rule and the cosine rule. Now in this case I've got two sides, AB and AC, but these are vectors, so I can find BC. That's going to be my first step. If I find BC, I'll have three sides. If I have three sides, then which rule will I use? We'll leave that for a while, come back to that. Let's find BC in the first instance. So the vector BC, right here, vector BC is given by, I can travel, I'll tell you what, let's detail the diagram a bit more. AB, put the arrows in, makes it easier for me to see, and AC. And the vector I'm trying to find is B to C, so it's going that way. So to travel that way, I can go back along here, so negative AB plus AC. So negative AB plus AC. It's the same thing as writing AC minus AB. Okay, which is equivalent to I minus 5j minus AB, so 3I minus 2j. Put that in brackets. Put that in brackets because once you've got a negative there, it's going to affect the terms in the brackets. So that's going to be I minus 3I minus 5j plus 2j. That gives me I minus 3I minus 2I and minus 5 plus 2 minus 3j. So I've got BC. Now I've got BC, I've got all three sides. Let's write this in here. Minus 2I minus 3j. When I look at it, it sort of makes sense to me. Let's write that as 2. It's from B, I've got minus 2 and then minus 3 down. So that makes sense. It looks as if it is reasonable. Right, now I've got the three sides. I'm going to use the cosine rule. Now the cosine rule, as I recall, is a squared is equal to b squared plus c squared minus 2bc cos of the angle in between, so cos A. So that's the formula we're going to be using. There we go. In order to do that, I need to find the magnitude, so I need to find the size of these vectors. In this first case here, the size of AB, let's write it here, AB, the magnitude of AB is given by the square root of 3 squared plus minus 2 squared. It's equal to the square root of 9 plus 4, which is the square root of 13. If I look here, the magnitude, let's write it here, magnitude of AC is given by the square root of 1 squared plus minus 5 squared, which is equal to the square root of 1 plus 25, and that's the square root of 26. And here, the magnitude of BC is given by the square root of minus 2 squared plus minus 3 squared. Hopefully you've started to notice it doesn't matter if it's minus or plus. The size is irrelevant. The sign is irrelevant to the size. So that's the square root of 4 plus 9, which is the square root of 13. So now I've got the magnitude of all three sides. I can apply my formula. And they've been quite kind in the question, because that's capital A, so the side opposite is small a. The capital C, so the side opposite is small c. Capital B for the angle, small c for the side. So I can use my a squared equals b squared plus c squared minus 2bc cos A, which is going to work really well. I'm going to rearrange it to find cos A. So I'm going to take my minus 2bc cos A over the other side and bring my a squared on this side. So that gives me 2bc cos A. It was negative on this side. Bring it on this side, positive, is equal to b squared plus c squared minus a squared, and cos A on its own is equal to b squared plus c squared minus a squared all over 2bc. So cos A is equal to, we can start to put the numbers in. B is square root of 26, so square root of 26 squared plus square root of 13 squared minus the square root of 13 squared. I can see straight away that those two are going to cancel. Let's just write. And on the bottom I've got 2 times the square root of B, 26, times the square root of C, 13. Now those two cancel each other out, that minus that. So we're left with the square root of 26 times the square root of 26, all divided by 2 times root 26 times root 13. The square root of 26 on the bottom will cancel with the square root of 26 on the top, any one of them, which leaves us with root 26 over 2 root 13. Now 26 divided by 13 is 2, so that gives me square root of 2 over 2. That's cos A. So cos A is equal to root 2 over 2. A is equal to cos to the minus 1 of root 2 over 2. And those of you who are happy with your right angle triangles, remember this one. That's 1, that's 1. So by Pythagoras, that's square root of 2. These are 45-degree angles because they're 1 and 1. And cos of 45 is equal to adjacent over hypotenuse 1 over root 2. And if we remove the square root from the bottom, we get root 2 over 2. So that's going to be 45 degrees. Good. So if you need to make some notes, hit pause, make some notes, and when you're ready, we'll look at one more example, hit play again. One thing to note, now we've completed this, is that if A is 45 degrees, and this is AB is root 13, and BC is root 13, we have an isosceles triangle, 45 degrees, root 13, root 13. So in the end, it was a right angle triangle. So it could have been easier if we'd known that from the start. We could have used Pythagoras. and SOHCAHTOA. But we didn't, and we had to use the cosine rule. Okay. When you're ready, you move on to the next example. Okay, for this example then, we're going to be looking at a parallelogram OABC. P is the point where OB and AC intersect. So P is the point where the diagonals intersect. Vectors A and C represent the position vectors A and C respectively, and they're on the diagram. Prove the diagonals bisect each other. So we've got to prove the diagonals bisect each other, cut each other in half. Let's draw them in. First things first, with a parallelogram, this is going back to your GCSE, you have to know the properties of a parallelogram. When we know the properties of a parallelogram, tell us that the opposite sides are equal. So if this is parallel and equal in size, then AB is equal to OC. So AB is also equal to C. And opposite, this side is equal to the position vector OC. So BC is equal to A. So let's look at the diagonals in turn. First, let's look at OB. So OB, the vector OB, I can get to the position vector B by traveling from O to A and then from A to B. So that's equal to OA plus AB. So I can travel along that way. So that means I can write it as A add C. Let's look at the other diagonal, AC. AC, to get from A to C, I can travel back down OA, so it's negative A or negative OA and then plus OC. So negative OA minus OA plus OC, which is equal to OC minus OA, which is equal to C minus A. So those are the two diagonals. Now if I look at the point P, the point P lies on the diagonal OB, but it's a fraction of it. So I can say that if I consider OB, the diagonal OB, this implies then that OP is a fraction of OB because they're parallel, traveling in the same direction. So let's call it lambda. So we say it's lambda, it's a fraction of OB. Whoops. So it's a fraction of OB. But I know OB to be A plus C, so it's going to be lambda A add C. Now if I consider the other diagonal, AC, this implies I want to use AC to also give me OP. So I want to write OP in a different way from lambda A add C. So using this diagonal here, I can travel along, to get OP, I can travel from O to A and then from A to P. So I can say OP is equal to OA plus AP. Now OA is given by A, AP is a fraction, it's a multiple, but it is a fraction of AC. So I'm going to use a different symbol this time. So I can say that that's equal to A plus, let's call it mu this time, mu of AC, which is C minus A. So I've got I've travelled OP in two different ways, but they've got to be equivalent. OP is the same as OP, so I can write then that lambda of A plus C is equal to A plus mu brackets C minus A. So they are equivalent to each other. If I expand that out, that gives me lambda A plus lambda C is equal to A plus mu C plus, oops, not plus, minus mu A. So on the right hand side, I'm going to gather my A's together. So I've got lambda A here plus lambda C is equal to A minus mu A plus mu C. If we carry on this half of the page, oops, there. So if I carry on this half of the page, I can say I've got lambda A plus lambda C is equal to, I'm going to factorize the A term, so if I take the A out, I'm left with 1 minus mu and mu C. Okay. So what I want to do now is solve this equation. To solve this equation, I'm going to look at what's next to the A. Okay, so I'm looking at, on this side, I've got lambda, and here I've got 1 minus mu. So I can say lambda is equal to 1 minus mu. Okay, so I'm looking at the coefficients of A. Coefficient of A on this side is lambda, coefficient of A on this side is 1 minus mu. So I can say lambda is equal to 1 minus mu. And then I look at the coefficients of C. I've got lambda again. And that's equal to, the coefficient on that side is equal to mu. So lambda equals mu. I've got two equations with two unknowns. Equation 2, equation 1. So if I sub for lambda in equation, well, sub for mu in equation 1, that means lambda is going to be equal to 1 minus lambda. So 2 lambda equals 1. And that implies then that lambda is equal to a half. And so mu is also equal to a half. Which means we've got our equivalence then, because if you look at, consider AB, OP is lambda, is half of AC. So that's telling us then that it breaks that in half. What I want you to do to test, put mu as a half here and solve that equation. See what it gives you for AC. Good. Those are your examples. So I'll put some questions for you to do now. So hit pause, make some notes, and when you're ready to move on to your questions, hit play again. Questions for you to do, exercise 11E. Not so many questions, just the 6, and a challenge question for you. So good luck, have a go.